Dear physics aspirants, right now I have the escape speed of physics, and this subtopic will come under gravitation. And here, the if a stone is thrown by hand, we see it falls back to earth. Of course, using machines, we can show an object with much greater speeds and with greater and greater initial speed. The object scales higher and higher heights. A natural query that arises in our mind is the following. Can we throw an object with such high initial speed that it does not fall back to the earth? The principle of conservation of energy helps us to answer this question. Suppose the object did reach infinity and that its speed there was Vf. The energy of an object is the sum of potential and kinetic energy. V before as before, W1 denotes that gravitational potential energy of the object at infinity. The total energy of the projectile at infinity then is E infinity is equal to W1 plus mv square f by 2, 8.26. If the object was thrown initially with a speed v1 from speed at a here you will see the speed v1 from the point at a distance h is plus re from the center of the earth. Re is equal to radius of the earth. Its energy initially was E is whole is h plus re whole plus half mv square I minus gm E by h plus re plus w1. By the principle of energy conservation, equation 8.26 and 8.27 must be equal. Hence, mv square I by 2 minus gm me by h plus re whole plus mv square f by 2. The RHS is a positive quantity with a minimum value 0, hence so much be the LHS. Thus, here you will see the RHS as a positive quantity with a minimum value 0, hence so must be the LHS. Thus, an object can reach infinity as long as Vi. It says that mv square I by 2 minus gm me by h plus re whole greater than 0. The minimum value of Vi corresponds to the case when the LHS of equation 8.29 equals 0. Thus, the minimum speed required for an object to reach infinity, i.e. escape from Earth, corresponds to half mv square I whole minimum is equal to gme and by h by plus re. If the object is thrown from the surface of the Earth, is equal to 0, and we get vi minimum is equal to root zme by re. Using the relation z is equal to m zme by r e square, we get vi minimum is equal to root 2 zre. Using the value of g and re numerically, vi minimum 11.2 km per second. This is called the escape speed, sometimes loosely called the escape velocity. Equation 8.32 applies equally well to an object thrown from the surface of moon with g replaced by the acceleration due to moon's gravity on its surface, and re replaced by the radius of the moon. Both are similar than their values on Earth, and the escape speed of for the moon turns out to be 2.3 km per second, about 5 times smaller. This is the reason that moon has no atmosphere. Gas molecules, if formed on the surface of the moon, having velocities larger than this, will escape the gravitational pull of the moon. So escape speed is, you have seen in the equation, with the help of equations. On next video I will provide you a lot more regarding this physics, and here are the one of the example you will see here. An answer I would like to provide you. Answer is here, you will see here. A point is note. A point to note is that the speed of the projectiles is 0 at n, but the non-zero when it strikes the heavier sphere 4m. The calculation of this speed is left as an exercise to the students. Next course of action will be Earth satellites. We will meet in next discussion with a lot more. Till then, thank you. Thanks a lot. Thanks for watching the video.